Okay, so in this video, we're going to talk about Trig sheet 8, and I'll make it in such a way that you're going to follow through because we're going to do each and every question. And you really don't need to know so much about differentiation. Just by listening attentively and following through and trying the questions that I'll be giving will help you understand the whole topic. This is basically going to be an advancement of the first two rules you learned from Trig sheet 7, which is first principles and power rule. So question 1, they are saying find the derivative of the following functions, compute the slope at the given indicated points. So the question 1, Roman numeral 1 is saying y is equal to 3x squared. Then we have minus 4x. The point given is 0, 0. So just get the derivative using power rule. Power rule says the power has to come down, multiply whatsoever is here as a coefficient, that becomes 6, reduce the power by 1, that becomes a 1, minus a 4. This is just a 1 there, so 1 times 4, that's 4, then 1 minus 1, that's a 0. So this is what we get as the derivative. Then we replace wherever there is x, put the x value given there. So this is going to be 6, 0, minus 4. This gives us a negative 4. That answers your question number 1. This is the slope that they wanted at the point 0, 0. That's basically the slope. Then part 2. Part 2 says y is equal to 1 minus 6x, then minus x squared. We find the derivative. This is negative 6 minus 2x. At the point where x is equal to negative 3, according to our question 2, the point we're looking at is this guy. So we replace it. This gives us a negative 2 multiplying negative 3. We have negative 6, then plus 6. This leaves us with a 0. So the slope is 0 for question number 2. Number 3, we're having y is equal to 2 over x to the power 3. This can be solved using quotient rule, but we don't have to go through all that. We can just write it like this. Then use power rule. This becomes negative 6x to the power negative 4. Then we're saying this is the same as x to the power 4. Replace wherever there's x, put negative 1 because we want the slope at the point negative 1, 2. So this is negative 6. We have negative 1 to the power 4. This is negative 6 and a 1. It leaves us with a negative 6. So that's okay. The next one is given like this. The last question on number 1. So question 1, Roman numeral 4, we have y is equal to 2x plus 1 over x minus 3. We have x to the power 3. At the point where x is equal to 1 and y is negative 1. So you can write this in a way that will help us to solve it using power rule because we don't want anything complicated. So dy dx is the same as 2 minus x negative 2. This is plus a 9, x negative 4. This is the same as 2 minus x squared and a 1, and plus a 9, x to the power 4. We put a 1 wherever there is x. This is that. We put a 1 there. This is a 2 minus 1 plus a 9. This here gives us a 9, 10, 11 minus that. We get a 10. So I'm getting the slope of the last question being 10. So hope you also got the same answers in your working. So that answers question 1. Then look at number 2. Number 2 is just an application that is related to question number 1. They're saying the slope of the curve y is equal to x squared plus ax plus b at the point 2, negative 4 is negative 1. So the slope is given to be negative 1. So we are going to differentiate what we have. This is question 2. They've given us y is equal to x squared plus ax, then plus b at a point 2, negative 4. So they're saying when we differentiate this, the derivative is 2x plus a, right? When we put 2 wherever there is x, when you put 2 there and the a, the slope should be -1. That's what they are saying. So this is a 4 plus a is equal to -1, meaning a is equal to -1 minus 4. So a is equal to a -5. So the slope was already gotten to be -1, yeah, at the point 2, -4. So no wonder we just had to replace. Then they're asking us to also get the value of b after we get the value of a. So we come back in our question and put back the a. So this is x squared minus 5x, then plus b. Wherever there is x, we can put 2. Wherever there is y, we can put -4, because that's a point that we've been told, was given. So we have -4. This is 2 squared minus 5. This is 2, then plus b. This is -4. This is a 4 minus 10, then plus b. This right here gives us -4 minus 4, then plus 10 is equal to b. This will give us a 2, meaning b is equal to a 2. Therefore, the whole expression is as follows, plus 2. So this is how the question was supposed to be. When you differentiate it and try to get the slope, you get a -1 at the point 2, -4. It's just a reverse way to check if you really understand what we were doing in question number 1. Now look at question number 3. So question number 3 wants us to differentiate these further derivative functions. So before we even start doing them, I'm going to give you a summary of what you need to know for you to be able to differentiate these. Yeah, so a summary here is going to look like this. So just a summary of further differentiation. So the derivative of sine is simply cos. That's what you have. And the derivative of cos is negative sine. So I have this. And the third one, you have the derivative of tan. dy dx of tan is just sec squared. It's easy to prove because you can use quotient rule, because tan is the same as sine over cos. Then if you have y is equal to e to the power u, the derivative of this is just u prime, then e to the power u. No wonder we say y is equal to ex. The derivative is the same thing because the derivative of x is 1. So no wonder we just write like this, which is the same as e to the power x. Then the next one, the fifth one, is that if you have y is equal to b to the power u, the derivative of such a function is u prime b to the power u, then ln the b given. For instance, if you have 7 to the power x squared minus 1, the derivative here is just going to be 2x, write back the 7, x squared minus 1, ln the base is 7. This is what you get as a derivative. So this is a procedure. Please don't forget, we differentiated the exponent. This is where the 2x is coming from. And if you have y is equal to ln u, we don't care what u is. We're just saying the derivative of something with a ln in front is the derivative of that thing over the original thing that you have. If I give us y is equal to ln x, the derivative here is just 1 over x. Why? Because the derivative of x is 1, then over there, the x itself. Then the last expression I can give you, because the rest of them are going to be derived, so we have something that looks like this. The derivative of this, let me put a u here. There could be anything there. You differentiate the u, then write over u, then log the base to e. That's what you get. Yeah, log the base that you had, then put the e there. So these are some of the rules that you have to know, and we'll be needing them to solve the following question. So look at question number 3. Question 3 says, find the derivatives of the following functions. So look at the first one. So I'll just be solving each one of them. The first one, so question 3.1, we have y is equal to sine multiplying cos, meaning we're going to use product rule because sine and cos are multiplying each other here. So u is equal to sine and your v is equal to cos x. So I'm explaining this assuming that you've already watched the 30 minutes video that explains the rules of differentiation, the first principles, everything else, the quotient and the product rule. So whenever two functions are multiplying each other, we always use product rule. So the derivative of sine, we are from just learning, it's cos, and the derivative of cos is negative sine. Hence, we can apply the product rule formula that says vu prime plus uv prime, this is equal to v times that, that's going to be cos squared, plus this times that, that's negative sine squared. This is just the same as cos squared minus sine squared. This is what you get. Now, you don't have to recall or show us your skill about on trigonometry, but it's okay to have or to complete this and write this is the same as cos 2x, right? You can leave it like this, it's okay, there's no harm. But if your knowledge on trig identities is a little bit sketchy, you can just leave it as cos squared minus sine squared. You don't really have to overthink things and remember all your trig ratios. Yeah, so this is okay. That's your number 1. Then your number 2, so your 3-2 says y is equal to sine, this is 2x. So here we're going to use chain rule. You let u be equal to 2x, meaning y is equal to sine u. And you differentiate here, du dx is simply going to give us a 2. dy du is simply going to give us cos. Cos u, I mean, this is supposed to be cos u. Then we multiply now. So I'm giving you the formal way of solving this so that you'll be able to score the full marks whenever you're answering exam standard questions. So this is 2 times cos u. Then this leaves us with a 2 cos. What was on the u is 2x. We replace back that, so we get this. The rule just says when y is sine u, the derivative of this is just u prime, then cos the u. So the u here happens to be 2x. Now that we differentiated it, that's the 2 that you are seeing in front here. Yeah, then we write back the cos because the derivative of sine is cos. So that explains question 3-2. Then question number 3-3, Roman numeral 3. So we have y is equal to cube root x squared. Then we have a cos this side, cos x. So here again, we're going to use, this is the same as 2 over 3. Then we have cos x. When you change this, right? Because it's the same as 1 over 3 then. Yeah, we change it to this. We're using product rule. The u is just x 2 over 3. Yeah, so in case you're unfamiliar with what has happened here, whenever you have anything to the nth term like this is the same as 1 over n. Now, there's already a number here which is a 2. So if there's a 2, meaning this has to multiply a 2, that's how it would have been this. Yeah, so this is how we are getting the 2 over 3 according to the rules of indices and exponents and bases. Yeah, so hope that's okay. Then the v is cos x. Then u prime is just going to be 2 over 3 x. This guy here minus 1, that's going to give us 2 over 3 minus 1. The common denominator is 3. That gives us a 2 minus 3. This gives us a negative 1 over 3. Yeah, so negative 1 over 3. Then v prime is negative sine. When you differentiate cos, it's always negative sine. Remember, we're using product rule, so this is going to be u times v prime, which is negative x2 3, then sine. Then this times that, that's 2 over 3 x negative that. Then we have cos x. So we have this. So this is what you'd get for your question number 3-3. So I'm trying to really solve everything a little bit fast because I don't want the video to be very long. Yeah, because it will be boring or you'll be reluctant to try to watch through everything. So you can try to reduce the speed if it's a little bit too fast for you. So y is equal to cos squared x. So this is the same as y is equal to cos and another cos. You can think about it like this in case the squared is confusing. So I'll show you two ways that we can do this. This is the first way. Think about it like this. So you have your u is cos, right? And your v also happens to be cos. This is method 1. We're going to use product rule. This gives us negative sign. This here gives us negative sign. So when we multiply, the dy dx is equal to negative sine x cos x minus sine x cos x. Then this is going to give us negative 2 sine x and cos x. This is what we are getting. Hope this is okay. This is just method 1. Now I can show you another method, which is method 2. We can use the chain rule. Yeah, so method 2 is where you have y is cos squared. It's the same as cos x squared. So we're saying, according to chain rule, we bring down the power, right? Differentiate what's inside. This is negative sign. Then write back what you had, then reduce the power by 1. So it becomes that. This gives us negative 2 sine x and cos x. Yeah, so this is just the shortcut way if we were to apply our chain rule. Yeah, for those who've attended the physical class on calculus, remember what we said on the chain rule. This is the formula I gave in class. That's the shortest way of showing chain rule. So let's go to the next question, number 4. Question 3-4. Yeah, so question 3-4 is y is equal to sine. This is x over 2. So like I said, I'm going to do these guys fast because of time. So differentiate what you're having there. If you want, you can use quotient rule, whatever method you're going to use. The answer will just be half. This is cos half of x. So this is what you get. Then the 5th one, you have, this is product rule as well. So please try to work this out. Pause the video first and compare with what we're going to get. Yeah, so we have this guy. This is 2x. Then you have u prime. That's 2e. So the derivative is just going to be x squared and e, then plus 2x and ex. This is what we're having. Then we are having the next question there is just number 7. Number 7, we have y cos x and sine x. Again, this is similar to number 1, so this is just the same as question number 1. So refer to question number 3-1. The answers are going to be the same because we're using the same method, which is product rule. So I'm not going to do this guy again. So try. So check this out, that it gives you the same outcome as well. Then look at question number 8, 3-8. So question 3-8 is y is equal to x over, there's e to the power x, then there's a minus 1, something that looks like this. Whenever we're doing quotient rule, the denominator is always going to be your v. So your v is there, e to the power x, then the minus 1 is there. Then your u, that's what you have. So u prime is just 1. Then v prime is just going to be ex. Yeah, so now we can replace, according to quotient rule, the formula is v u prime minus u v prime over v squared. So v times this guy, that's going to be ex minus 1, then minus, we're having x and v prime, which is this guy there, everything over our v squared, which is ex then minus 1 squared. We can just leave things here because there's nothing that's going to be common anywhere to cancel out or anything. Yeah, then look at number 9. So number 3-9, they're saying y is equal to x plus e to the power x. So we differentiate this. dy dx is equal to 1, then plus ex. That's what you get. According to the rule, right? This is just going to be 1. That's going to be ex still. Then according to this guy here. So what's the rule here? The base is, our b is 2. So here, this is just going to be, differentiate the power. The answer is 1. Then write back what you have. Then say lean the base. So this is going to be your answer there. That answers your number 10. The same applies to your number 11, 8x. It's the same thing, the dy dx. This just gives us a 1, hit the power x, then ln 8. So it's the same as 8x, then ln 8. Yeah, that's what we have. Then the last one, they're saying the 12th one, there's y is equal to tan ex. So according to the rules, the derivative of tan is sec squared, right? But we differentiate whatsoever is here. That's going to be ex2. Then we say sec squared and put ex. Because ex is like the theta or something. So that's what you're going to get. Yeah, so this answers your question number 3. Yeah, I hope it's a little bit helpful comparing the answers that you've gotten. Then look at number 4. Number 4 says, differentiate the following with respect to x. So the rules that are going to be applicable depend on what is necessary, on what you need. So question 4.1 says, differentiate the following with respect to x. So we are having question 4. The first one, this is y is equal to ln. Then we have x squared plus 3x, then plus 4. That's what we have. Minus 4. So this is a minus 4. So to differentiate this, we are going to have chain rule. Yeah, so we're just going to differentiate what's inside. That's going to give us a 2x, then plus a 3. Then over the whole thing that we have, x, then plus 3x, then minus 4. Now this is just like a Crookes method, sort of. Yeah, so now we're going to show it in a proper standard manner. We're going to let u be equal to x squared, then plus 3x, then minus 4, meaning the function is now y is equal to ln u, whose derivative, when you say dy du, the derivative here is 1 over u, multiplied by du dx, which is just going to be 2x plus 3. So when you multiply them, this is what gives us 2x plus 3. Then the u down is back to our original expression that we had. So this is how we are supposed to show it. So this is the outcome for the first one on question number 4. Then look at question number 5. So question number 5, I mean number 4.2, they are saying y is equal to ln. This expression given here is x squared sine x divided by 2x minus 1. So here there's a mixture. The overall rule that is going to be obeyed is the one that follows the ln. But then how do we differentiate the expression which is inside? This is just going to be as follows. So question 4.2. So question 4.2, y is equal to ln. Then we have x squared, then this is sine x over, we have a 2x, then plus 1. So we're going to let u be equal to the x squared. Then we have sine x over 2x plus 1, meaning y is equal to ln u. We can differentiate this side. This is just going to be 1 over u. Because the derivative of u is 1, then put the u down. Then this side is where the problem is, because we're having a mixture here. We're having, this is quotient rule. We're supposed to use quotient rule to differentiate this, because our u, so instead of u, I'm going to use another letter. So let me use something like our omega. Our w is equal to x squared. Then we have sine x. Then our v is 2x plus 1. So I'm avoiding to use u because it has already been utilized. So when you differentiate this, we're using product rule on this part. We have x squared and sine x. Then this is 2x, this is cos x. So we have that, which is x squared cos x, then plus, this is 2x, then sine x. Then this side, the v prime, is just going to give us a 2 when you differentiate it. So the overall derivative of u, which is gotten using quotient rule, is just going to be the v, the guy down, which is the 2x plus 1 multiplying the omega prime, this guy here, which is x squared cos x plus 2x, then sine x, this whole thing, then minus the other way around. So this is going to be v prime now 2 times omega, that's our 2x squared, then sine x, everything over the v is 2x plus 1 squared. So this guy that we've gotten here, the whole lot of it, this is u prime, this whole guy here, this is u prime that we've gotten, and we're going to multiply. That's our du dx. That's like the derivative here. Yeah, so the u prime, yeah, so the derivative, so du dx is simply what we've gotten here, the whole thing that we've gotten. Yeah, because this is your omega, so this is what we've gotten. Then we multiply it by the u. So the answer is just going to be this whole expression that we've gotten over the original expression that we had. So it's going to be your 2x plus 1, and you have x squared. This is cos x plus 2x and sine x minus the 2x squared. Then this is sine x, everything over 2x plus 1 squared. So this divided by the original question, which is just the same as x squared, then sine x over 2x plus 1. So this is the answer that you're supposed to get. Of course, you can simplify it, but this is literally what you're going to get. Yeah, some people will finish it off. This is supposed to be the same as if you do the multiplication here, when the cross multiplication, because we are saying everything here is being divided by, this is being divided by x squared, or rather let's say it's being multiplied now, because we can change the division to multiplication. That's 2x plus 1, and then we have x squared, then we have sine x. So you can cancel this and cancel that. Then this is going to lead us into getting 2x plus 1. Then we have x squared, we have cos x plus 2x, then sine x, minus 2x squared, then sine x. Everything down is 2x plus 1, x squared, then you have sine x. So this is what you're supposed to get as the derivative of the second question, or number 4. It's a bit long, I know, but you just have to isolate the rules. It will be easier that way. Yeah, so that's what we're supposed to get. Look at the next question on number 4. So I'll peruse here because it's straightforward. We're just going to use quotient rule directly. Yeah, so I'll be a little bit fast now, because like I said, I don't want the duration to be very long. So we have question 4. Question 4, number 3. This is y is equal to 3x, then over, we have 3x, then plus a 2. So the u is the 3x, then the v is the 3x, then plus a 2. When we differentiate this, so this is going to be, differentiate this, we get 3x, then ln 3. Remember the rule for this. Then v prime is just going to be 3x again, then ln 3. So now we're going to have the derivative is just the v, which is 3x plus 2, multiplying the 3x ln 3, minus the 3x, then the 3x ln 3, over the v squared, which is 3x plus 2, then squared. So you can just leave it like this. It's easier this way. At least we don't get to simplify a lot of things. Yeah, we don't have to complicate anything there. Then the next one is chain rule. So if we're using chain rule, this is just going to be question 4, number 4. So chain rule, this is going to be 2x4 plus 1. Then we're having a tang there. That's what you get. Yeah, so if we're having a tang there, that's a function, right? So we say what? We say this is a function. We can just let u be equal to 2x 4 plus 1, meaning y is equal to u. Then we have tan x. When you differentiate this guy, du dx, we get 8x3. Differentiate this guy with respect to u. So we're differentiating it with respect to u, not x, right? So we're going to differentiate what we have there. That's sec squared. Then we have u tan x. Then we have ln u. So we multiply these two guys. dy dx is equal to, we're going to have 8x3 multiplying sec squared u, then tan x, then you have ln u. We replace where there's u, we put back everything that we had, which was just a 2x to the power 4, 8x3 sec squared, this is 2x to the power 4, then plus 1, and the tan, then this is just ln the 2x4 plus 1. That's what you get. So the first temptation was to do what we always do for chain rule. You were probably tempted to say 2x 5 plus 1. You wanted to bring down the tan down. So this is only done if the power is an integer. That's when we do that. Not when the power is a function again. Yeah, so we cannot apply that. You cannot bring the tan and then differentiate this and write. Then you're going to write tan x minus 1 as the new power, which is totally wrong. Yeah, so here please take note on how I have manipulated it. Yeah, so we're using chain rule whenever you have a weird power, remember, or whenever an integer power that you cannot evaluate. Yeah, so this is the main reason why chain rule works. The next question is question number 4v. So 4v says y is equal to x. Then we have 2x, then this is plus 1, everything over. We have ex, then we have sine, this is 3x. So we're simply going to use quotient rule. That's another rule here that we are going to apply. Of course, the other rules, but this is just going to be firstly quotient rule at first glance. Then now to differentiate them separately, we have to apply some parts we have to do chain rule, some part we have to do just normal product rule. So this is going to be like your omega. So we'll say this is going to be your omega, your x. Then let's say this other going to be our t, the 2x plus 1 to the power half. So omega prime is 1, then t prime is half, then this is going to be 2x plus 1, this is going to be negative half. So this part cancels because it's half of 2, right? It's okay to not involve it at all. Then we'll say the overall derivative of your u when you differentiate it is just w times t prime. That's going to be x, 2x plus 1, negative that, this times that. That's going to give us the 2x plus 1 to the power half. Then for this other part, if we want to differentiate v to get v prime, we'll have to use product rule as well. So according to this, our omega is ex and our t is sine 3x. So this is just going to give us ex. This one here will give us t prime. Bring down the power. This is going to be cos, then sine squared. That's what we have. So this is going to be this times that. That's 3e cos sine this, then plus. Yeah, so we have this. So now that we have the derivatives, we can now proceed to use our quotient rule, because the main rule is quotient rule. So quotient rule just says we need our v dy dx dy dx is equal to your v, so we can say this guy here, the ex, then sine 3x multiplying this guy, that's x, then we're having 2x plus 1, then plus you have 2x plus 1, then this is minus, we're having this guy times that, x 2x plus 1, this is going to be we're multiplying with everything, that's 3, that's going to be ex, then you have cos x sine squared x plus ex, then sine x, then everything that you're having here divided by v squared. So v squared according to our question is ex, then sine 3x, then square it. So this is how we're supposed to do question number 5 on 4, so 4, 5. Then the last one on question 4, 6, this is under log, there's a formula already for this. There is a 2, then there is a 3x plus 1. So the dy dx is just going to be 3 over 3x plus 1, then log this. Yeah, so this is what we do for question number 4. So hope this helps a little bit. So I'm going to pause this video right here. Then in the next part, we're going to talk about question 5 to 9. Then the last other part will be 9 to the end. Yeah, so feel free to attempt the following questions. So a task here of part 1 of what we've done is to differentiate y is equal to sine 3x with a cos x. The next one, you have y is equal to cos 2x and sine 3x. And the last one, you have y is equal to e, this. Yeah, so this is what you have. For those that are registered, please make sure that I only make the second part of the tutorial sheet available after you've submitted the task. Please feel free to inbox me on WhatsApp, the usual number that I use to send posters and announcements. So thank you so much for watching. If you have any questions, please do confirm on WhatsApp.